Morning. Cool. All right. So we are looking at 8 o'clock here on the East Coast. It is Sunday, August 28th. Holy cow. I cannot believe we were at the end of August 2022. Last I checked, it was 2020, and now it's 2022, and I'm just confused all around. But welcome. My name is Whitney, or Whit. I am a GMAT, GRE, and executive assessment instructor and productivity coach here at Manhattan Prep, and super excited to get to be hanging out with y'all. So this evening's plan is going to be a quant lesson, and it's going to be a lesson that you might look at me at first and think, Whitney, this is silly. Why would you be teaching us how to add and subtract and multiply and divide? But wait for it. I am here to show you the way to add, subtract, multiply, and divide without a calculator, and by letting go of all of the like weird, stack and like longhand business that we learn when we're young. And instead, the plan now is for us to work with these computations in a way that is intuitive, so that we can start to do a better job of estimating. So when I ask students all the time, do you like to estimate? Are you a person who estimates? They're always like, oh, I wish I could estimate, but I just don't trust it. I don't trust it. And the reason why we don't trust estimation is because, frankly, we're doing it wrong. But primarily it's because we've been taught how to do math in very unintuitive ways. And so we don't have a good concept of numbers, like what the value of a number is, and then what the value of a grouping or a system of numbers might be. And so the plan, and so stick with me because I promise you're going to think this is crazy, but you're going to love it. In like just a minute, you're going to love it. The plan is for us to shed all of that and instead start doing math in a way that actually helps us naturally practice estimation. And if you're going to turn around and take the test, even in just a day or two, some of these techniques will immediately speed up your work on test day, right? That's my goal. Yeah, that's my goal. All right, so here we are. Let me get a screen up so that I have something to scribble away on. Hopefully everybody can see that okay. So what I'd like for you to do is to grab a sheet of paper, just, pull out a random sheet of paper out of your notebook and sort of set it off to the side. And what we're going to build is we'll be building 4 little cheat sheets. So you'll probably actually be able to fit all 4 cheat sheets on the front of a sheet of paper. But we'll have an addition cheat sheet, a subtraction cheat sheet, a multiplication cheat sheet, and a division cheat sheet. Yeah, all of the above. It'll be so great. Yeah. But that way you can pull your little piece of paper off to the side. We're going to do a whole bunch of work, but I want you to walk away from this with a quick and dirty little cheat sheet of how do I want to approach problems instead of doing a bunch of really longhand math. So I'm going to start with a problem. Here we go. Let's do this. Let's try 518. And actually, let me just do this in nice hand print, right? Like I'll actually print this out. So 518 plus, let's go 289. And I want you to just start writing on your paper. How would you solve this? Right? How would you solve 518 plus 289? And I'm going to take a guess. I'll go ahead and start to sort of stop you here. I'm going to take a guess that many of you are writing 518 over 289 and adding them like that. Yeah? Can I get a like +1 or a yes, or does that sound
yes.
right?
Yes, correct.
Yeah. So let's imagine that I am signing up for, some college classes. And I've got some tuition fees or, maybe an online course that I'm going to take. And I find out that the course is 518, but there's an add-on for 289. And I want to know, like, how much is this going to cost me really? I am not going to write down 518 and 289 on my paper and start adding in this way, because I'm going to start with the part of the number, right? 8 plus 9 is 17, carry the 1. I know that the units digit of my total is 7, but frankly, that's a pretty worthless amount of information. right? Like if I was like, it's going to cost me 518 plus 289, for you to say it has a units digit of 7 is like not helping at all, right? So what I'd rather do is be able to conceptualize these numbers and estimate. And so we're going to start estimating. But in order to do that, I want us to right away stop doing this, period. Right? The only time I ever do this is if I have some gigantic number and I'm adding like a 1-digit number to it. Otherwise, I don't add this way anymore. So what I want you to do instead is we are going to still break up these numbers. We're going to split them up before we stack them. So rather than just stack two numbers, this is my little split and stack method that I like to use. I'm going to take 518 and I'm going to make it 500, 10, and 8. And I feel like I can convince y'all that that's the same as 518. And then I'm going to take 200, 80, and 9. Notice that I am, in fact, still stacking these numbers. The difference, though, is that I'm going to start my addition from the left and move to the right. So when I look, I'll go 500 plus 200 is 700. 80 and 10 is 90, so I'm up to 790, about 800. And if I'm looking at answer choices, I'm going to stop. You're right, like I might not need to go all the way to my units. But right now I've got 700, I've got the 10 and the 80 is 90, the 8 and the 9 is 17. So 790, 807. Yeah. Okay. So I want you to try it for me. Let's do the same. Again, let me give you a couple of ones to try. So let's have you do the following sums. Let's go 286 plus 457. Let's go 465 plus 387. I like these 7s and these 8s, apparently. And then let's go 123 plus 278. So I want you to try each one of those. Let's take about 30 seconds or so to run through those on your own. All right, how are we feeling? Type in the chat window for me to everybody, or you can jump on the mic if that's easier. What do you think? Good? Not so good?
It's taking time.
Takes a little bit of time.
Yeah, just it's not in the habit.
Yep, it's not in the habit. Yep. Anybody else? Find it any easier?
Yes.
I like this because I'm not carrying numbers, right? I don't have to carry. And so we'll list these out. I got 280 and 6, 450 and 7. I'm gonna add them up. I got 600, 8 and 5. That's our 13. So 130, and 6 and 7 is 13. So 730, 743. All right, I got my 465 plus 387, 460 and 5, 380 and 7. Stack those suckers. I got 700. 6 and 8 is 14 with a 0, so 140. 7 and 5 is 12, so 700, 840, 852. And again, I'm only going out to the units digit if I have to, right? It might be enough to be like, man, it's like 840-ish. I can also do 100, 20 and 3, 270 and 8. And I'm looking at a number that's 300 plus another 90 plus 11. So 390, 401. Okay, you can write them out this way. I've also seen people write them as, 100 plus 200 is 300, 20 and 70 is 90, 3 and 8 is 11. And so 400 and 300 is 700, 60 and 80 is, write it down, 60 and 80 is 140, and 5 and 7 is 12. And so you can also split them and add them in their hundreds, then in their tens, then in their ones, and then you'll add across the bottom as needed. So that's kind of the next level of this, where you start to see the numbers as, okay, that's 700, it's another 140, it's another, and add it directly from the left to the right. Okay, so we've got this split and stack method. But before we go down the path of split and stack, or before we kind of fully abandon this, just want to check, how are we feeling? Good? So good so far, maybe a little bit.
Good.
Killer. All right, I want to take the same set and think about how we estimate. Okay, so one of the things that comes up a lot is when I talk to people about estimating, often what they come back to me with is rounding. Okay, so estimating would mean to think of the entire system, at least in my mind. An estimation is where I pull information from throughout the system and I make manipulations that help simplify the work that I'm going to do, but ideally keep me accurate. If we start to just round numbers, I'm going to round it up, I'm going to round it down. When we round numbers, what we're doing is we're following an arbitrary set of rules. Like at this point you round up, at this point you round down. And we're not taking the system into consideration. Sometimes it works out, sometimes it doesn't, right? So if we kind of take these same pieces again, if I were to say round these two numbers, I would be most likely to round this down to 500, this one up to 300. Now, many people see that as like too big of a round. And so instead would say, okay, I'm going to take this to 520. I'm going to take this to 290. And sure, I've made my life a little bit easier, but I'm still going to have to stack in a way that I wouldn't have to stack if I just said 500 plus 300. Right? So if I were to just go this like very big, like I'm just going to take it to the cleanest numbers I can come up with. If I took this to 500 to 300, I'm not bad on my estimation. It's pretty good, actually. And in fact, it's probably pretty good in something like this one as well. I might round this one down to 100 and this one up to 300, right? And that's going to take me to 400. But what happens when my numbers are maybe not quite as pretty? For example, here, if I round them both up and I take this to 500 and I take this one to 400, I'm getting a lot further off. Now, I can tell that I'm getting further off because I've rounded two numbers up when I was adding them together, but now I'm having to track that. I'm having to keep that in mind. And so same thing here, if I were to round this 286 up to say 300, if I take this one all the way up to 500, it's going to be ugly again. Maybe I keep it at 450. And so I'm a little closer, but the point is that if all I'm doing is manipulating individual numbers, as opposed to thinking about what I'm doing with those numbers, then I am going to be introducing error into my estimation without having a really clear understanding of what error I've introduced. And so I'm not going to trust estimation because it's a little bit, luck, whether my numbers are rounding in directions that are appropriate. So what I'd like to do is, instead of just like, I'm going to round this number to, I don't ever use the language of round, right? Like that's just like not a thing I do anymore because we're not in, first and second grade. We can think more complexly than that. Right? I'm not going to try and jam myself back into a bunch of arbitrary steps and rules. So instead of these like little generic versions of rounding, what I want to do instead is consider what is addition, right? So addition is two of us bringing our supplies together and putting them into one pile. So let's say that, Belton and I are pooling our resources. We're going and we're going to pool some cash so that we can go buy popsicles because North Carolina is hot right now. So Belton brings some cash. I bring some cash. Now, if Belton decides to show up with extra cash and I show up with extra cash, we now have way too much money. If Belton shows up with not enough and I show up with not enough, now we have way too little amounts of money. So if we want to try and sort of keep the amount of money we're bringing the same, we need to offset. So if Belton brings more, I bring less. Or if I bring more, Belton gets to bring less. And so when we estimate, instead of thinking of what am I going to do to 518 and what am I going to do to 289 or what am I going to do to 286 and what am I going to do to 457, I want you to think, what am I going to do to share the amounts? So what I might do in this case, and so I'm going to clear off our space a little bit here. Let me make a little duplicate and then clear off some of this scribbly math. So I'm going to clear off some of our space here. But what I want to do is think about how can I compensate through an exchange? Okay, so addition is going to act like an exchange. So I want to take my 289 maybe up to 300, or I could take my 518 down to 500. It doesn't really matter which one I'm going to chase. For this one, I'm going to say, okay, I need this number to go up about 10. Right? So I need 10 from this stack to make this one pretty. So if I bring 10 out of this, I'm at 508. I'm going to add that 508 to this 300, and I'm going to put myself at 808, which isn't exact, but gosh darn it, it's close. So what we think about doing is, all right, I'm going to take some out of this pile and give it to this pile. Or I'm going to lift this one up while I pull this one down. And so I want you to think about how you can use that same technique for each one of these, so that you don't even have to really do any real addition. So you're going to be rough. Notice I said, like, I'll take it up about 10. I didn't get specific about like, oh, I'll take it up 11. So I'll take it up about 10, and 10 is an easy enough number to subtract off from this. And so I want you to try that with these three. So let's take again, like 20, 30 seconds to see how quickly we can now add all three of these numbers just with the exchange. So now how did the speed feel on this one?
Faster, but a rougher estimate.
Faster but rougher. And so what we need to start to think about is how precise do I actually need to be? So I want to have both of these tools in my toolkit, because if I'm on the last step of my computation and my answers are far apart, I'm going fast but rough estimate. If I'm early in computation or it looks like my answers are really close together, then I'm probably going to split up and stack. And so a good thing to do while you're practicing, and so not when you're necessarily timed on a specific question, but grab two numbers, first try to estimate, and then split and stack and see how close you get. So for something like this one, I might take this up 40. So I need 40 out of this pile to make this one, right? I want this one to be 40 higher. So I can take that, where did I go? Oops, there we go. I can maybe get back there. There we go. I want to go 40 higher so that I can pull from, there we go, 40 up on this side. So I need it to come from the side. So this will be 240 plus 500. So 740. That's not bad. I'll take 3 off. For this one, I'm going to take this one up. Ooh, like if I go 15, 15. So if I like give about 15 from this one, that takes me down to 450. That 15 going on to this one would take me to about 400. That takes me to 850. I won't lie, that's a pretty darn good estimate. 2 off, I'm not hurt. And then this one is, I want 22. That one's 23. Oh, they're basically like 1 for 1 at this point. I'm going to take 100 and 300, and there's my 400. Yeah. Okay. How we feeling? Hopefully good. Hopefully good. So what I'd like to do is take both of these same techniques and try them with subtraction. Okay, so the first one I want you to try with subtraction. So let's try, we'll take this similar number, and then we'll start to build our cheat sheet. Let's take the number 518 and subtract off 259. And I want you to try it with the old school stack and subtract business. And tell me what starts to happen pretty quickly when you stack them the old school method. What do you find? What starts to happen that's a pain? Who's willing to share? Are y'all fans? You're welcome to type in the chat window if you'd rather not come away. But everybody likes this longhand subtraction method? I'm surprised.
You have to start carrying.
Yeah, I have to take this, like, I gotta borrow from here, and then I got a 9, and then I gotta borrow from here, and then I gotta find, and like, ugh. And I'm back on that units digit again, and I don't care about the units digit. That part's not useful to me. So what I'm gonna do instead is I'm gonna split, right? I'm gonna stack them up and then go. So I'll take my 500, my 10, and my 8. I'll then take a 200, a 50, and a 9. And now in this case, I have to subtract all the pieces off. So when I'm thinking about addition and subtraction, I'm thinking money exchange. So if I have $500 and give you 200, I have 300 left. If I only have 10 and you want 50, I still owe you 40. If I have 8 and you want 9, I owe you 1. So I have 300 minus 40, that's 260, minus another one is 259. Okay, so let's try the same. Again, we'll take about 30 seconds. Let's try it with these 3 numbers. And let's do this one. All right, how did the subtraction go, y'all? Good, bad, indifferent?
Quicker.
Quicker? Feeling better? Broth, how
Yes.
about you? Yeah, same? Oh, you're back on mute. I lost you. Broth, let me know if it was better or worse. But awesome. All right, so I'll take my 200, my 70, and my 3, my 100, my 70, and my 8. I'm subtracting all these off. I got 100 left after that one. I got nothing left after that one. I'm owing 5, so 95, 100 minus 5. I've got 480 and 9, 120 and 3, and I'm coming across with subtractions. So 300 left in this transaction. I got 60 left here, and I got 6, so 366. And then 460 and 5, 380 and 7, coming across again, subtracting at all points. So I've got 100 left here, 60, but owe you 80. I still owe you 20. I only have 5 and owe you 7. I still owe you 2. So down to 80, down another 2 to 78. Okay. So we already talked about how estimation for addition is this, the compensation is through exchange. In order to estimate with subtraction, and let me tell you, estimating with subtraction is a powerhouse. That said, we have to get our heads wrapped around what estimating and offsetting and what subtraction actually is. So if I take the numbers 518 and 259, the easiest way I can describe or explain subtraction is as a difference or a distance. So when you think about numbers, right, addition existed as this idea that, you know, Belton shows up with some cash and I show up with some cash, and now we have a pile together. That's, we add it all together. Subtraction is the undo button of addition in the world of math, right? So addition is like the foundation. That's the, in fact, only operation in math. And so we've got addition as an operation, and then everything springs up from addition. So subtraction becomes the undo of addition. Once we start adding the same number over and over and over again, we move to a shortcut that we call multiplication. Right? So multiplication is a shortcut of addition. So it is a creation of addition. And then we have division, which is an undo of our multiplication. And then when we have repeated multiplication, we end up in exponents. So in fact, exponents is a layer on a layer for addition. And then exponents need their undo, that's roots. So when we start to think about the operations in the world of math, addition is our one. Right? That's our foundation. From that, we then say, well, what happens if I have to give stuff back? Right? Because we already talked about Belton and I like joining forces, but now it's like, wait, I'm starting with an amount of money and I have to give some to Belton because he did all this like really great work and now I have to pay him for it. So if we think about a number line, and I'm going to take this all the way out to the number 0 for a second. So we'll come all the way down here. So let's imagine 0 is here. If I were to, and you could almost imagine setting this line upright, like a vertical line. And it might help actually with your subtraction to think of a number line that's vertical. So if I have my like vertical number line, right? And so here's 0, here's having nothing. If I have $518, I'll put it right here. If I have a big stack of $518, that means that my meter is filled all the way up to 518, right? Now, if all of a sudden Belton's like, hey, just kidding, you owe me $259 for this like amazing job I did for you. It's like, oh, okay, well, Belton wants this stack. So I started with this stack of money, but Belton is now going to take, for good reason, this stack of money. And so subtraction is me trying to figure out how much is left, because we don't subtract from the top. We subtract from the bottom, which is super weird, but we do, because that's how numbers worked out. We subtract from the bottom. And so this difference between 518 and 259 that we figured out was in fact just 259, right? If I recall, it's just itself. So this number is 259. If I want to estimate, when we were adding and when we were using addition, I would estimate by making one value got bigger while the other got smaller. Okay, but what happens to my estimate? So I'll come over here again. What happens if I round 500 down, or 518 down to 500, and I round 259 up to 300? What happens to my estimated distance between my 2 points on my number line?
Decreases.
It decreases. It's too little now. This distance of 200 is too little. It's too small. Okay, what happens if I go the other route and I say, all right, I take this one up to something? I wouldn't, because it's too whatever, but let's say I took it up to 600, took it up to something big. I took 259 all the way down to 200. Now look what's happened. My estimation is 400 apart, which is way too much for my 259. So if I want to try and keep my estimate the same, right? I want to keep this little bar, this little segment, the same distance, but I want to start moving a number. Like I want to start taking 518 up or take it down or take 259 up or down. What do I need to do with the other number if I want to keep this straight? So if I take 518 down, what do I need to do with 259 to keep my distance the same?
Down.
I have to move it in the same direction. Exactly. So if I take 518 down to 500, I've come down about 20. I need to bring this one down about 20. So I'm going to take this number down from 259 to 239. And then I'm going to subtract. But that's not a really fun number to subtract, is it? 500 minus 239 or even 240, right? If I decided to be like clean about it, 500 minus 240 isn't the most lovely thing in the planet I've ever subtracted. What if instead I said, okay, no, I'm going to focus on the bottom number. I'm going to take 259 up 40 points. So I'm going to take it up 40 points and I'm going to take it to 300, which means I'm going to take 418 up 40 points to 558. What if I have to subtract now 558 minus 300? Which of these two numbers would you rather subtract? A or B?
B.
B, right? And 558 is not a pretty number. It's way uglier than 240 is. But when we're subtracting, when the bottom number is pretty, life is easy. Because if you think of the stack, 500, 0 and 0, 200, I now have 40 and 0. Like I actually have to do some work here. If I had kept this at 558, like I could have literally, the beauty of having a bottom number be only a number with zeros is that I can go back to just stacking them, but I actually still get to start with the left. It's just 258. Like I could just come right across. And 258 is awfully close. I mean, they're both going to be really close, but this one's going to be an easier move to get to. So here is your trick for subtraction for estimating with subtraction. You're going to move your numbers in the same direction because think of that subtraction line as like a rope that you're holding tight between the numbers. So if one of those numbers gets bigger, it drags the other number up, or if one gets smaller, it drags the other down. They have to move in the same direction. So we're going to slide our numbers, and you can think of it as slide them up and down, whichever. And the one we're going to focus on is the bottom number. The number we're subtracting, I'm going to try and make that one clean. Usually I make it clean by just adding. Adding is often the easiest thing to do in general. It's just like, let's just add our numbers up. So let's do it. Let's try that same thing, but with the rest of our numbers. So I want you to try estimations with these three. And note, just as a reminder, what we're doing is, in this case, I decided to take them both up about 40. So I made this 558 minus 300, which was 258. Not bad estimate, right? So take 30 seconds, try those other ones on the bottom. All right, how we feeling? Good? Maybe?
Yeah, good.
It's good, right? I love this method. I love this method a lot. So I'm always going to focus my attention on the bottom number. So I'll take this one up about 20. So again, I don't have to be particular here. I'll take them both up about 20. This is going to go 293 minus 200. That gets me to 93. I'm pretty pumped about that as an estimate. I'm going to take this one. I'll still take it up. I'm going to take it up. Let's call it 80 just for good measure. And so again, or if you feel more comfortable, take it down, but take it down something clean. So like, let's take it down 20. So if I take this one down 20, I'm taking it all the way down to 100. This one, if I take down 20, it's 469. And so I've got 369, which I'll be honest, still pretty close. This one I'll take up, given how this one looks, I'll take this one up about 15. So if I add 15 to this, it's 7580. So 480 minus 400, and there's my 80. So things look pretty good. Okay. All right. So if we go to our addition and subtraction cheat sheets, let's do it. So on the addition side of our cheat sheet, what I want, the first thing I kind of go for is, if possible, I estimate with compensating exchanges. Okay, one goes up when the other one goes down. Right, so I take one up and I take the other one down. The second thing I'll do, or a second item, is if I need precision, I will split and stack. The last thing we need to do is what happens when we have strings of addition, and we'll talk about that in just a second. On the subtraction side, I estimate my compensations are now shifts, which means I'm taking them both up, or I'll take them both down. But once again, if I need precision, I'll split and stack. Now, it's rare that we have strings of subtraction, but it's one thing if we have strings of computation with subtraction involved. And so we'll see what that looks like. So I do want to make one note, or not just one, but I want to make a couple of notes on precision before we finish up with this, and then we'll knock out multiplication and division. You're going to love those. So notes on precision. Couple of things here. So in general, when I'm looking for precision, answer choices are a very good clue in terms of how precise I need to be. So if answer choices are really far apart, I probably don't need to be very precise. If answer choices are a hair apart from one another, I might need to be a little careful. Next up, potentially, there we go. The second thing is that the uglier the numbers are, so the like gnarlier the numbers look, the less I am expected to actually compute. So it doesn't mean that I'm supposed to round, right? Like be very cautious of the like, I'm just going to round some numbers. You're going to think about how you can adapt numbers in the system so that you can stay accurate. I'm going to be pretty cautious when I'm very early in a problem. So the earlier I am in a problem, the more likely I am to maintain some level of precision, because if I have a bunch of steps that I have to go through, any error is just going to kind of carry through the remainder. And then last but not least, and this, ideally would go without saying, but you never know, right? Sometimes I have to shake it as well. But if a problem says language, right? If it says things like approximate or closest to or nearest, right? If it says any of those things, I am 1,000% estimating. I mean, I'm going to estimate anyways if I can, but if they say words like approximate, then I'm going to go nuts. Like I'm going to go absolutely ham. Okay, so let's talk now about this, a quick chat about what to do when I have strings of numbers. And again, I really want you to take from this is that we're estimating in a system, okay? Like in a system. So let's say a problem gives you the following string of numbers to add. Do I just start at the left and get going? So I'm going to take 60 plus 80 is 140, plus 90 is 230, 330, 430, 440, 450, 500, 600, 7, 800. Is that the way to do this? Can someone please tell me a better way to do it than to do it what I'm just doing right now? Or to stack them all up and start adding vertically. What else can I do?
Look for the numbers that can make 0, 0.
I'm gonna
Yeah.
look for
Grouping.
stuff that I can group that would be pretty. So I'm thinking about addition, means I'm piling a bunch of stuff together. Why don't I go ahead and pile stuff together that's pretty? Like 60 plus 240 is 300. And my 80 and my 120 is 200. And my 90 and my 210 is 300. And then I've got 100 and 150 is 250. I can add from the left to the right now. 3, 4, 5, 6, 7, 8, 9, 10, 50. Okay. So I'm not going to necessarily add in the order that they tell me to add. I'm going to try and lump things together in whatever order makes it easier to handle. Okay, what about this? What if this was a list of numbers that in the process of solving, you found out you were going to have to add? And these are from modified, but from real questions. So what in the world? Your gut is going to want to tell you to start rounding. Your gut is going to say, okay, well, I can get rid of those 9s. Maybe I don't care about those. But, you know, that's a lot of 9s and 8s I'm getting rid of. Or maybe I round this to like 80 and 9,200 and 35,500 and 28,000 and 2,400. But have I really saved myself like a ton of work? Because this doesn't feel like estimating to me. This feels like some rounding so that my computation is a bit less awful. But this is not estimating. Can I pile any of these numbers together in ways that might make them easy? What do you think? For example, what happens if I pile these two numbers together?
28,000.
It's about 30,000 with a little bit of extra, right? Like it's 28,000 plus 2,000 and there's like a little bit of extra. So, okay, this is about 30,000 with a little extra. This one is, let's just call it 35,000, also with a little extra. So I've got a little extra, I've got a little extra. If I give all those little extras to this one, I'm going to call that one 10,000 because it's going to catch all these like little extra lumpy bits. And so my estimation is 75,000. All right, just for proof. And also to as a quick reminder, the questions are invented. So the numbers that show up in these problems are contrived. They're meant to look ugly, but then work out cleanly. So if I were to add these up, so let me make sure I get it right. 78 plus 9209 plus 35,509 plus 27,909 plus 2372. What do you want to bet? How close to my 75,000 you think I am? I would absolutely take this bet. I am 77 away from a number that is as big as 77,000. This is gold, right? So when you've got strings of addition, look at not how do I manipulate an individual number, but how do I work the numbers in the system so that I'm making lots of them pretty at the same time, not just one arbitrarily. As I do that, I will actually make the math easier and I will be more accurate at the exact same time. All right, let's try the same thing, right? Let's try the exact same thing, but for subtraction. And now let's just imagine that you have like you've converted some fractions or you converted some percentages or what have you, and you've converted them into this list of numbers. What could I do? So again, I could start from the left and do 10 plus 50 is 60, plus 20 is 70, 80. And now I have to subtract off 25, which isn't the end of the world. I take off the 20, so that's down to 60. Take off another 5, that's 55. Then add 5 back on, that's 60 plus another 10, that's 70. Was there a less painful way I could have done that? What do you think?
Subtract the closer numbers, 25 and 20.
I could subtract just the 25 and 20. I love it. Could I use anything to fully get rid of my 25? Because what's really ugly right now is that 5.
Yeah,
Is
bunch 10 and
The
15.
last two.
Yeah, I could take this 10 and this 15
Yeah.
and kill the 25 with it. And now I'm done. So if what I know is ugly is the 5, I'm like, can I get rid of that 5 somehow? So even if I just combined these two first, I'd be at a minus 10. That step first would have taken out that ugly units digit. So if we start to think about how, again, estimating in the system, not only are we faster, but we are more accurate. Right? And that's really the goal. I don't want to just be fast for speed's sake. And so there was a great question in the Q&A, like for multiple choice answers, should we always be estimating, right? Or is it the best method? You need to be armed with multiple methods, because if this is early in a question, I might not want to estimate far because I may have several steps. If it's at the end and my answer choices are sufficiently far enough apart, then I will potentially, I will always estimate at any point where I think I can. The only way you're ever going to think you can, though, is if you practice. So you force yourself to try. So for strings of addition, the way we will estimate is, I like to think of this as group into easier piles. Whereas with strings of computation with subtraction involved, what we're trying to accomplish is that we want to group to find eliminations for the subtractions. Trying to get rid of those subtracted pieces. Trying to get rid of all those little subtracted off pieces. Okay. All right, let's do this thing. Here comes the real money. And so we're going to see how quickly we can get through these. So for multiplication, right, if I gave you the number 7 times 12, hopefully I can convince you that what this means is 7 times 7 times 7 times 7 times 7, 12 times, or the number 12 multiplied 7 times. So 12 times 12 times 12, 12, 12, 12. So yes, you should know your multiplication tables up to 12, but let's say you conveniently forgot. I can use the split method for multiplication as well. Okay, so the split method for multiplication is going to be to take my 7. I can write this as 10 plus 2, and then I'm going to distribute. 7 times 10 is 70. 7 times 2 is 14, 84. Yeah. So let's try a couple more. 8 times 25 and 6 times 39. So let's do 2 more. I want you to try those same ones yourself. So I've got 8 times 20 plus 5, or 160 plus 40 is 200. I've got, could have 6 times 30 plus 9. Did anybody do this one differently though? 6 times 30 is 180 plus 6 times 9 is 54. And now I'm like 100 plus 80 and 50 plus 4. This isn't the most fun. So 100 plus 130 plus 4 is 234. Did anybody do this a different, maybe faster way?
6 into 40 minus 6.
Yeah, so I'm gonna write this as, I call this the like your closest exit might be behind you. So this is 6 times 40 minus 1, because I can just as easily write 39 as 30 plus 9, or 40 minus 1. So 6 times 4 is 240 minus 6. There's my 234. Not bad. So if I've got numbers, I'll split and distribute. If the numbers start getting big, there are some tricks. So let's imagine we have the number 19 times, or let's pick one that's a little bit smaller. Let's go 14 times 16. I can write that as 10 plus 4 times 10 plus 6. And then distribute. So I'm going to distribute this just like a quadratic. So the 10 times both of these terms, that's 100 plus 60. I'm going to multiply the 4 through, 40 plus 24. And notice I'm just kind of stacking them under things that they look like. And so I've got 100, 100, and 24, so 224. I could also do this with, let's say, 19 times 21, and maybe I keep the 21 and make, just break up one of these two numbers. So I could do something a little different with this one. I could look at 19 as 20 minus 1, and 21 as 20 plus 1. When I multiply this through, when I distribute this, does anybody notice what might happen?
A squared minus B squared.
This is my a squared minus b squared. This is my difference of squares. So I'm going to take the 20 and carry it through. This is 400, 20 times 20, plus 20, minus 20, minus 1. I just got a squared minus b squared. So 400 minus 1. So here's the deal. You can always do 2-digit by 2-digit. I'll show you what happens when we get bigger than that. Once we get or you can do 1-digit by any number of digits is fine. But once you get bigger than 2-digit by 2-digit, if it goes 2 to 3 or 3 to 3, typically then what we're going to start looking at is units, digits, and some other methods of factoring. I'll show you in just a second. But this is a trick that I like to call find the middle. So notice that the middle number here is 20. If the middle number is a number that I know how to square, then I can find this difference of squares technique. Turns out I can do the exact same thing here as long as I know my perfect squares up to 20, which, by the way, you should learn. So this is going to be 15 minus 1 times 15 plus 1. There we go, 15 plus 1. And so once you multiply all these pieces out, 15 squared is 225, plus 15 minus 15 minus 1, I'm going to get 224. So to show it to you in kind of a patterning, if I had 19 by 21, or 18 by 22, or 17 by 23, or 16 by 24, I find my middle number in all of these cases. I'm then going to write it as 20 squared minus whatever that amount is that I'm having to go over and under. Plus 3 minus 4 plus 4. So this would be 20 squared minus 1 squared, 20 squared minus 2 squared, 20 squared minus, because I'm 3 away now, 3 squared, 20 squared minus 4 squared. So this is 400 minus 1, 400 minus 4, and so on. So I call this trick find the middle. So here's your find the middle trick. 2 more multiplication tricks, and they just get cooler. So let's imagine, and so the find the middle is good when, I should show you, here's find the answer to, let's do this one really quickly. What is 12 times 14? Find your middle. My middle is 13. That's going to be kind of like, think about it almost like when we were talking about addition, that estimation. If I was actually allowed to give like 1 from the 14 to the 12, and it would be 13 times 13, I'd be pretty close. So I'm going to take my 13 squared, but I'm going to subtract off the 1 that was getting exchanged. And so 13 squared is 169 minus 1 is 168. Okay. If, however, you were given something ugly like this, you are not in a million years supposed to actually multiply these numbers together. And I'll say this, rounding this number up to 11,000 and this number up to 600 is going to make your answer way too big. That said, you might do that, but what you'll do first is you'll check your answer choices. If this is the last step in your math, which it often is, what we know is that the units digit of a product is the product of the units digits. And the reason for this is that when we're multiplying numbers like these, so my 10,982 times 579, I'd start by multiplying the 9. 9 times 2 is 18. 9 times 8 is 72, 73, carry the 7, and blah, 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 blah. I then drop a 0 because the next step is what I'm basically doing is I'm multiplying 10,982 by 500 plus 70 plus 9. So my next pass through is to multiply by 7D. So I bring down the 0. 7 times 2 is 14. 7 times 8, and then I keep writing. Now it's time to multiply this number by 500. So I bring down 2 zeros, multiply the 5 across, and off I go. So the units digit of a product is only coming from that very first multiplication. So if I'm multiplying these two numbers, my units digit will be 2 times 9 or 8. And so in this problem, there's only one answer choice that has an 8. That's the one. If there's more than one that has an 8, they're going to be very, very far apart. And your estimation of like, all right, let's just call it 11,000 times 600 and see what we get. Like that's too big, but meh, that will get you down between the two answers that have 8s in the units digit. Okay, so we've got one final trick for multiplication. So let's grab the multiplication cheat sheet, just so I can sort of show you the pieces of it. So our multiplication cheat sheet, I'm going to show you the order in which I look for stuff. Okay, so for multiplication, the first thing I'm going to do is that units digit. So the very first thing I'll do is check the units digit. Now, again, that's only for a final step, because it means that I'm looking at the answer choices. So I'm checking the units digit against the answer choices. Okay, the next two things I'm going to do, we'll call them 2A and 2B. And we haven't seen 2B yet, we're about to. And then I've got 3, split and stack method. Or sorry, split and distribute in this case. And the note for here is don't forget, sometimes your closest exit is behind you. So don't forget subtraction. You can split and use that subtraction to cheat. So for 2A, here are little like, do these tricks apply here? Ooh, maybe. Find the center, right? And I'm going to try and use that difference of squares. So I have one other one, and this is to use factors. So I want you to try the following, right? So we'll go back to our 8 times 25 again. What's the easiest number in the entire world to multiply? So if I had the number 327 times blank, what would you want that number to be?
Yeah.
There's like 3 numbers I'd
or
want it to be.
one.
I'd want it to be a 0, a 1, or a 10, right? A 10, 100, 1,000, right? I want this to be something very, very simple. So my wish list here would be if this could be a 0 or a 1, hell yeah. But if not, I'll take a 10. So the final trick for multiplication is to think of the factors of the numbers you're dealing with and look for tens. How do I find a 10? A 10 is any 2 and 5. So in this case, what I might do is say, oh, okay, this is 2 times 4 times 5 times 5. And just like we added in whatever order we wanted, 2 times 5 is 10, 4 times 5 is 20. This is 200. Alternatively, I could also have said, oh, this is 2 times 4 times 25. That 4 and 25 is the 100. So this is 2 times 100 or 200. So I want you to try that same thing. Lots of different ways to go about it. I want you to try the same thing with 24 times 15, 18 times 30. Because sometimes it actually pays to break a number up to find an easier way to multiply it. If I'm being really honest. And then we'll do the last one is 7 times 8 times 50. All right, so how might I take apart 24 by 15? I got a few ways I could do it. But one way might be to say, all right, let's call this 2 times 12 times 3 times 5. Cool. My 2 and my 5 are my 10. I just wanted a 5 out. That's all I want, that 5 loose. And then I want a simple like 2 or 4. And then I've got 10. I'll just do it this way. 10 times 2 times, or 12 times 3 is 36. And so my answer is 360. Not the only way to do it, for sure. Not the only way to do it. Plenty of different ways to do it. But a nice one nonetheless. 18 by 30, I could change this to, 2 times 9 times 30. So 2 and 30 is 60 times 9, where 9 times 6 is 54, so 540. It's one way I could go about it. I could also break it up into, that's probably going to be the easiest way to do it, but you could also kind of make this, like pull pieces out and do like a 6. I'm going to have you like 6 times 3 and then 3 times 10. So if you didn't see this one up front. And then the last one, I might say, okay, I'll take my 7 times 2 times 4. I'll leave my 50 where it is. My 2 times 50 is 100. 7 times 4 is 28. And so I've got 2,800. What do you think? Feel like you could try it? Potentially. Maybe. So I'll add that to our cheat sheet. Our multiplication cheat sheet here is then I want to be able to find the 5s and 2s. And so for both of these are more of a like, do these tricks apply here? So first I check my units digit if it matters. And then I just see, do these apply? Do either of these apply? And then if I need to, I can go the longer route of splitting and distributing. But usually one of these three things will have applied before I got down here. Okay. When it comes to division, and this is actually one of my favorite areas, is division. Let's imagine you have the number 96 divided by 8. I think for the most part, we all know, hopefully, what that is. That's 12. But let's say I've forgotten some of my, like, times tables, and I'm having a kind of like blah moment in the middle of a test, panic. I could do the same split and distribute with division that I did with multiplication. So I could call this 90 plus 6 over 8. And then I would distribute, and I'd say, okay, this is 90 divided by 8 plus 6 divided by 8. This is what we would call splitting the numerator if there were variables involved. But 90 isn't divisible by 8, nor is 6. So that was kind of not a really smart move. Is there a better breakdown of 96 into two numbers that would be divisible by 8? What you got for me?
80, 16.
Yeah, so I'm gonna break this number into 80 plus 16. 8 goes into 80 10 times, 8 goes into 16 twice. That gives me my number is 12. Pretty powerful. Okay, so given that, because this is my favorite way to divide, I want you to find what is 105 over 3. Let's go. Actually, not 105. Yeah. Let's go 105 over. Yeah, 105 over 3 is good. Let's then also go. I'm gonna give you some fun, tricky ones. 207 over 23. And I want you to try this 207 over 23 with longhand division, just for funsies. And then 183 over 9. So if you tried 207 over 23 with longhand division, you very quickly, 23, you very quickly encounter the fact that 23 doesn't go into 20. So I just have to know what this value is. I just have to know precisely what it is. So we'll use this split and then distribute, right? Because we've got split and distribute basically. I'm going to find my closest multiple of 3, and I'm going to be lazy. I'm going to find something super easy that is like quick for me to calculate. And so 90 is nearby, right? So I'm looking at things like 90, 120, 150. So 90 plus, 15 over 3. 3 goes into 90 30 times. 3 goes into 15 5 times. This is 35. 207, my closest multiple is actually 230. So I can use that. Closest exit might be behind you. So 23 goes into 230 10 times minus the 1 time. The answer is 9. We can even use this method when things aren't divisible or to figure out if something is divisible. For example, is 183 divisible by 9? Well, there's a divisibility trick where if I add the digits, I can find out. 8 plus 1 is 9, 10, 11, 12. Since 12 is not divisible by 9, 183 isn't. But that doesn't tell me what this is. I'm going to come up with my closest multiple. This number is 20 plus 1/3. So I can even get to an estimation or a perfect decimal equivalent if I want, which I really, really like. I'm a big fan. I'm a big fan. So I can move through a lot of division by this split method really quickly. It can be very, very nice. So that's one of my goals, is split and distribute. In the same way that we were looking for those multiples, right? To find numbers that were easy to add together first, or numbers that were easy to like cancel out my subtraction. I can use the same thing with factors. So I can use factors to make, we saw how we used factors to make multiplication easy, right? It made multiplication easy by looking for my 2s and 5s. A way that I can use factors to make my division easy is just reducing fractions. So, right, I want things like 81 over 27. And so I'm going to look for things that 81 and 27 have in common. 81 is 9 times 9, and 27 is 3 times 9. So I can cancel. Just in the same way that we canceled addition subtraction, we're looking for ways of canceling in division. So in addition, we want to lump into easy piles. In multiplication, we want to multiply into easy piles. With subtraction, we want to cancel stuff that's being subtracted. In division, we want to cancel the stuff that's being divided. So they're analog. So in this case, I'd take my 9 divided by 3 and I'd just be down to 3. You could do that same thing, like let's say we have 105. So try these couple, 105 times 15. Let's go 64 divided by 16 and 70 divided by 14. That one takes about 35 seconds or so just to try them out. We're down to the last 2 tricks. So I can find things that they're both divisible by. Sometimes that's just 2. Like I know that both of these numbers are even, so I might reduce it to 32 divided by 8, and then that's enough for me to see. Or I see that they're both divisible by 8, and I write it as 8 times 8 over 2 times 8, kill off my 8s, and now my answer is 4. 105 and 15 are both divisible by 5. So this would be 21 times 5. This is 3 times 5. Kill those, and now I know my answer is 7. So never underestimate the power of a quick reduction. Both of these are divisible by 7. I might just see that directly and say, okay, this is 10 over 2 is 5. Or you write it out as 7 times 10 over 2 times 7 as you're practicing. Start killing stuff off. Okay, one other trick to use factors to help make division easier. What's the easiest thing to divide by? Well, that'd be 1. But what happens if I want to divide by something that's almost as easy, like the number 10? What do I get when I divide by 10? I get 1.8. So dividing by 10 or 100 or 1,000 is just a move of my decimal point. It's just a move of my decimal point. So this would be 1.8. So if I had something like 24 over 5, I could write this as 20 plus 4 over 5. 5 goes into 20 4 times plus 4/5, which is 0.8. This is 4.8. I could have also gotten there by saying 24 times 2 and 5 times 2 becomes 48 over 10, which is 4.8. Look for your opportunities to get denominators of fives or of tens and hundreds and so on. You want to get those zeros floating around out there. So give this one a try. Let me throw a couple your way. So if you had, let's go 81 over 45, 50 over 15. So the ones that aren't always obvious, 50 over 15, and 9 over 75. And we'll list these on our cheat sheet. Call it a night. All right, so I might come after these with a couple of different things. Like, well, they're both divisible by 9, because I'm trying to get a 5 down here. So 9 times 9, 5 times 9, I kill off those. And now I double top and bottom. I got 18 over 10. There's my 1.8. Well, I could sit here and try and divide them both. In this case, right, I might kind of get like a weird set of numbers. How do I get, right, that's not divisible by 3 if I want to try and get it over. So, oh, sorry, that was supposed to be a 51. No wonder that was probably tricky. There we go. Right, that was a 51. So, oops, come back here. Let me give this one back to you in a color that matches. All right, so here's my 51. So I could say that this is, you know, like I want 51. That is, I can split it up. So maybe that's easier here, looking for my multiples of 15. Or I could try and like know my multiplication tables. So this one is 17 times 3 over 3 times 5. Double both of them. That's 34 over 10 or 3.4. But notice in this case, what might have been easier is 45 plus 6 over 15. 15 goes into 45 3 times. Plus 6 over 15 is the same as 2 over 5 plus 2/5. And so there's my 3.4 in that direction as well. For my last one, I can divide both by 3. So this becomes 3 over 25. Multiply both by 4. I get 12 over 100 or 0.12 or 12% or whatever number I need. As you start to learn, if you haven't already, there's a bunch of multiplication shortcuts or divisibility shortcuts. Excuse me, like whether a number is divisible by 2 or 3 or 4. But there are not divisibility shortcuts for numbers like 7 or 8 that are useful. So you could end up in situations, really nice situations, where it's like, I don't know, is 151 divisible by 7? I'm not entirely sure. Kind of looks like it might maybe be. So what do? I check. I say, oh, this is 140 plus 11. Nope, that is not divisible by 7. So I can make quick checks even of some ugly numbers if I know how to split up or find factors and reduce. All of that without a calculator. All of that without a calculator. So my division cheat sheet, now that we're here, we're gonna wrap up on our division cheat sheet. The order in which I'll do things is I will always look to see if I can reduce using factors. So my first step for all of these will be reduce fractions or reduce using common factors. So anything that the numerator and denominator have in common, I'm going to try and cancel out. My next step, if it applies, my trick, if you will, for division is going to be to get it over the tens. So that's my sort of trick, if you will, for division. And then I've also got split and distribute. And sometimes, don't forget, your closest exit is in fact Still behind you. All right, friends. I've got you on your cheat sheet for addition and subtraction. Note on some precision. I got you on your cheat sheet for multiplication and division. Here's what I will say. Estimation, even when we do the tiniest little things in multiplication and sometimes division, estimation is kind of a little bit all over the place. So I will give you a little bit, just one note. Estimation is going to work in the exact same way as it does for addition. You want to move in opposite directions, but know that estimation is no longer precise at all. In fact, small estimations, small offsets can have very, very big impacts on your overall amount. We can also use estimation with division. Division is the analog to subtraction. We want to move numerator and denominator in the same direction. Increasing or decreasing them both by the same amount isn't going to be precise, but it will give us, we'll stay close. So if we're trying to round or manipulate numbers to get close, we want to keep division moving in the same direction, just like we wanted subtraction moving in the same direction. For multiplication, if we want precision, we want things moving in opposite directions, just like we did for addition. And again, no longer precise, not even in the littlest bit. Same cautionary tale here. All right, friends. Let me say thank you so much for spending time and going over with me. I really, really appreciate it. If you're looking for more free options, by all means, come hang out with us, take a class. We got GMAT classes all the time online, so you can sign up for any of our session ones for free. If you have not yet, go check out our free prep hours on YouTube. If you're seeing this recording as part of our free prep hour on YouTube, you can click on the lessons below and get our entire playlist. On our free prep hour, we have well over 100 hours of free video of all kinds of strategy, just like this one, that we don't always have time to get to show in our full-time classes or with our tutoring students. So we offer them to y'all. And as a note, we also have a bunch of on-demand products. You can study directly from our books, but we've also got our GMAT Interact, and you can take a trial run of the first week of GMAT Interact fully for free. This isn't one of those, give us a card and then you have to remember to cancel. There's nothing ever to cancel with us. So you can always attend a class or try out any of our on-demand products. No credit card coming out of the wallet. So you just let us know if we can help. Reach out. We love getting to do this stuff. Check out our resources page for more. And otherwise, have a wonderful rest of your evening or morning for those of you that's morning. And good luck with your studies. It's been a pleasure to get to work with you. Thanks so much, y'all.
Thank you.
Take
Have a good day.
care.
Thank you. Have a good one.
Bye, friends.
Thank you.